Hey everybody, John Weniger, Allied Machine, product manager here at Allied. Welcome into our booth. We want to talk to you quick about some new additions we have to the Allied product line. So namely the TA Pro M geometry. So it's a new insert grade that we've released, designed for 300 series stainless, 400 series stainless, all of your austenitic pH style stainlesses, even your heat resistant super alloys, so your Inconels and your titaniums. So any of the super alloys, it's a brand new addition to the TA Pro line that we're highlighting here at IMTS. We'll get quick in on this insert. It's some of the cool new features are OD margin grooves that we've put on the side of this insert. The real benefit of that is you can, eliminates built up material on the side of that insert and allows coolant to get through the margins of the tool. Doesn't sacrifice the surface finish or anything like that. It really helps improve tool life. As well as our AM460 coating, so a double layer coating works really well in the high heat applications that you'll see in the stainlesses and those heat resistant super alloys. So this will run in our TA Pro holder, dual gun drilled, enhanced coolant outlets. It's a real high penetration style tool that we've came out with, anywhere from stub to 15 times D, 7/16, 4.375 to 1 7/8, around 1.875, and 11.11 millimeter to 47.8, I think. So great offering here. We're going to run a quick demo as well over here at the machine to showcase this tool. So let's head over there. Alrighty, so I'm here with Rob Brown. He's going to help us walk through this demo here today. Rob?
All right. Hi there, I'm Rob Brown. I'm the engineering trainer here at Allied. And what we're going to be running today is a TA Pro M geometry insert. It's an 1 1/8 inch diameter, going about 1.5 inches deep into a piece of 304 stainless steel that's about 160 Brinell in hardness. Now the machine that we're on is a Haas VF3. That's about a 30 horsepower machine. And the coolant system on this machine is 1,000 PSI, about 8 gallons a minute, or I believe is what the coolant flow is on it. So the speed and feed we're going to be running today is 260 surface feet and 7 thou per rev. If I remember correctly, that comes out to about 79 meters a minute and 0.18 millimeters per revolution. So Dave, if you're ready to hit go, we will. Okay. Oh, and the coolant that we're using is a synthetic coolant. So that's a little different than if you tune into our regular videos when we're back in the shop in Dover. But this tool is going to make, a manageable chip. It's not going to be nice little tight 6s and 9s, but it will be something that's not going to wrap around the spindle of the tool, things like that. So whenever it's done with its cycle here, we'll gather up some of the chips, and while I'm showing you that, Dave will get the part out so we can see the quality of the whole. So we'll open things up here. I'll grab some chips, show those to you. By the way, that cycle time was about 40 seconds, just to give you kind of a ballpark number. So here's take a look at the chips. Like I said, these chips aren't like what you typically see with like an alloy steel or something like that, but it's a nice, manageable chip. Usually with 300 series stainless, a lot of times what you get with that is that the chip will wrap around the tool body and creates a lot of problems, because then you go to the next hole and there's already chips already stuck to the tool. So by having a chip like this, it's going to go through the conveyor well. It doesn't make a big rat's nest, doesn't wrap around the tool body, so it gives you a nice outcome. So let's take a look at the hole that we created here. Once again, this is an 1 1/8 inch diameter. And really what you got here is a drilled hole finish. Based on my expert finger here, I'm going to say that it's probably somewhere in the neighborhood of about like a 150 or 200 RA finish. So it's a nice drilled hole finish, especially for this type of material, because 300 series stainless has a real tendency to want to tear instead of cut nice and clean. So this is actually a pretty decent quality hole. So that's what we got with the TA Pro M geometry. And I'm going to come back over here and I'm going to turn it back over to John here so he can offer up his thoughts.
Kick it off, yeah. So cool demo. We got a lot of other neat demos here at the booth today. I think around 20 different demos with all of our different product offering. A lot of different booth locations set up. We got application engineers, field sales engineers here to help you guys answer questions, talk through some applications. So come on by, stop through, and look forward to seeing you.
All right, thank you.